Hi everyone. This is the last class of this semester. So it's about the finding the area between the given curves or lines and the volume using this only one integral. Okay. So let's start. So here we have the region. So first we need to sketch the given curves or lines. So here we have this curve. We first sketch that. You know how to sketch. If you have any trouble with sketching these graphs, you can go back to the first worksheets, I guess. I don't know the number, but you should know them. So this line y equals to x is here. Okay, now we have two lines. One of them is called f, one curve and one line, and the other one is g of x. Okay, so then the area between them is this, right? This one. Okay, now what do we do? First we need to find the intersection points. Okay, it means this and this. So we equalize them. Okay, we have these equations, so we have this equality. Now basic operations give us these two roots. One of them is 4 and the other one is 1. So here we have 1 and 4. Okay, these are intersection points of this line and curve. Now the area is a function, the first function minus the second one. How do we write this? How do we decide the order? We take the function which has greater values, okay, at the same points. So which is greater? It's obvious that y equals to x has greater values than the curve. For example, if you take this point, you see this is x, and on the curve you get this point, and on the line you get that. Okay, so as using this idea, we get the order. Okay, so the first one is here g, and the second one f. Okay, f of x. Now we have this integral. Then how do we decide the boundaries? Here we see the intersection points are there, right? And the bounded area is between them. Okay, we integrate with respect to x. That's why we write the boundaries of x. Okay, here we have 1 and 4 as in here. Okay, so we get this as the area. Now we have this. Here we have this curve y equals the square root of x plus 3, and another one is x plus 3 over 2. So the bounded region is here, right? The area between them. Now the intersection points, we equalize them and get x equals to minus 3 and x equals to 1. So one of them is here, minus 3, and the other one here, 1. Okay, now which one has greater values? This one, the curve. So we first write it, then the second one. And what about the boundaries? Here we again integrate with respect to x. So the boundaries of x are minus 3 and the greatest one is 1. Okay, the intersection points. So it is minus 3 and 1. So we get this value. Okay, and this is homework. Now we're given these curves. First, find the intersection points. We equalize them again and get this one. Okay, 2y squared minus 2 equals to 0, so we get this. So y equals to plus minus 1. Now we have these curves, then their intersection points 1 and minus 1. Okay. Now remember that, or remark that, the boundaries are with respect to y. So it would be easier to write the integrand as in terms of y than in terms of x, right? So the first one, and the one who gets greater values, is this function 1 minus y squared. We first write that, and then the second one. Okay. Now the boundaries are obviously minus 1 and 1. Here we have. So it's the area is 8/3 then. So as you see, the only thing you need to do is to sketch the graphs, right, properly. Then find the intersection points. Then write the integral. Okay. Also homework. Now we have this second squared and 8 cosines x. We're given this interval. Okay. First, find the intersection points. It's hard to directly sketch them, right? So let's first find the intersection points. We equalize them. Here we have 1 over cosine squared equals to, right, by definition of second, equals to 8 cosine x. So we have this cosine x equals to 1 over 2. And in this interval, we have only 2 roots here, plus minus pi over 3. Now, they are already boundaries, remember that, okay? Now we can then sketch easily the graph of cosinus. We already know the graph of cosinus, okay? Now what about second squared? So it's by definition 1 over cosinus squared, right? So it means, this equality means that you can take the symmetry of this curve, this cosinus, right? It's because if cosinus equals to 5 at some point, then second x will be 1 over 5. If cosinus equals to 1 over 2, cosinus second x will be 2, right? So it's exactly this. It's logical because to take the symmetry, right? So you take that, and you see we have 8 cosinus x, right? So we have here 8, that's why we have 8. At 0 cosinus 0 is 1, so we multiply it by 8. And this is not cosinus x, but 8 cosinus x, okay? This is, sorry, this is cosinus x, sorry. I can't, okay, and this is the symmetric graph of with respect to that, with respect to this line, as I said before, using this equality, okay? And this is 8 cosinus x, okay? We only multiply the image of the graph, okay? Now, so what do? We have this area, right? So we have, we easily see that 8 cosinus x takes greater values than this one. So here we have 8 cosinus x minus second squared x, okay? Now the boundaries are these ones as we found before, the intersection points. Okay, so what do we have here for this? We have 8 sinus x, and this one's integral is tangent x. So we have these boundaries. It's that equal to this. Now, the only problem of these questions, this kind of questions, is to imagine the solid, right? So first, you're given these boundaries, okay? It's easy to check that. So here we have y equals to 3. So let's start with this. We have x equals to 0. And we have y equals to 3, right? Here we have. And y equals to square root of x is this. So we have this region, okay? Now, what do? We rotate it about the y-axis, okay? About this. We need to rotate it. Then the solid will look like this, okay? So it means here it's 3-dimensional, right? It's an object in 3 dimension. So here we have 3, right? We rotate it. We rotate it as this, okay? And if we rotate this curve, here we'll see something like this, exactly as in this form, okay? And then what do we have? We need to find we need to cut with by some plane this one, okay, horizontal way. So if we cut this, the intersection will look like a circle, right? So we need to find this radius r, okay? Okay, we need to find this radius r. Okay, what's that? So recall that the equation, this equation of this curve is y equals to square root of x, right? So if we say here r, then x equals to r. So we need to compute this, right? This one. So y equals to square root of r, then r equals to y squared, okay? So in terms of y, we found the radius of this circle. Now what's the area then of this cut? It is pi y squared, right? Pi times the square of the radius, it's y to the 4. So this is the area. Now what do? Then the only thing is to integrate this area with respect to y, of course, right? We found some function in terms of y, so with respect to y. As we said with respect to y, then we need to find the boundaries of y, which are 0, right? Through this we integrate 2, 3, because this circle range from 0 to 3, right? This was random. This was only one circle. In terms of y, we wrote them. So when y gets bigger values, this will get bigger, right? This will get bigger. So this was for some fixed y. So when you change y, you will get the area of that circle. Okay. So here we have these boundaries then, 0 and 3, right? From this to there. And the remaining part is easy. You know how to integrate. Okay, so first you find the region, then you guess the solid, then you cut with a plane, okay, and you guess the area of that cut, okay, and then you find the boundaries and take integral. Now we're given these ones. Now what's the bounded region? We first write, I'm guessing these polynomials are not that hard actually to sketch. Yes, it's not that hard. So here we have, you don't have to sketch exactly the graph of them. You can approach, right? So don't worry about it. Now we have this curve, which is this polynomial, and the red one is this. And we have these boundaries too, x equals to 0, which is y-axis, and x equals to 1, which is here, right? So it's bounded by this line, okay? Now we will rotate it about this, y equals to -2, this line, okay, here we have. So if you rotate it, you will obtain, so here you have something like that too, right? Sorry. I tried to do the same. So the same object. So if you rotate it, you will get some circle there. Not there, but here. You will have some circle around it, right? So the solid will look like this. Okay. Now here, what do we have? This is, it's hard to explain actually. This is this line, y equals to -2x squared. And this is, sorry, this is y equals to 6 e to the -2x, okay? Okay, it's, this green is above the x-axis. I made a mistake there. Not a big mistake, but so you can think that this green curve is above the x-axis because it cannot be negative. E to the ta is greater than 0. Don't forget that, okay? But it's not so important. Okay. Now, if we rotate it, we will get something like this. Now, we need to cut this by a line, by a plane, sorry. So the plane will be something like this, okay? We intersect them. So the cut will look like exactly this. For example, take this one, okay? Okay, the cut will look like this. Here we have. Now we need to find the radius. Here we have the radius of this inside circle and the outside circle. Now, what's the radius of this one? Here we have y equals to -2, and there it touches to this green curve, right? The green curve is, here we have 6e to the minus 2x, right? So we have 2 to the is 6e to the minus 2x plus 2. So here we have inside circle, circle's radius. Okay, this is R1. Okay, now what's R2? It's this. Okay, again we have 2 points there plus this one. Here we have, right? It touched here. So we have this plus 2. Okay, so here we get this one. The circle outside, the radius of the circle outside. Now what do we have? We need to compute the area. Okay, what's the area of this this shape? It's this one's area. It's pi times r2 squared minus pi times r1 squared. It can be written as in this form. Okay, so here we have this. Here we have this area. Okay, r2 squared here, r1 squared here. Now we have this then. Okay, so what's the volume? Volume is, here we have the area. We wrote all terms in terms of all functions, all radius, the area, all functions in terms of x. So we need to find the boundaries of x, right? So what's that? The boundaries of x. Here we had 1, right? The above boundary, as in here, and below boundary here 0, right? So x changed between 0 and 1. Then the boundaries of the volume will be 0 and 1. And the rest is easy. Okay. Now this is the last question. We have here the boundaries again. We write 2x plus, we sketch 2x plus 1. Here we have x equals to 4, this pink line, and y equals to 3 here. Then we have a triangle between them, right? Now we rotate it about x equals to -4, okay? And the solid then will look like this, okay? So the inside circle is based on y equals to 3, right? As in here, y equals to 3. And above it is here, sorry, it is here. What's that? It's on this line, y equals to 2x plus 1. We plug x equals to 4, as in here. Then we get 2 times 4 plus 1, we get 9. So it is 9, okay, here, above. Now, the boundaries are then 3 and 9. Let's cut this solid, okay? If we cut it, the cut will look like this, because here we have this one, okay? this circle, and we have this circle too, okay, and inside it's empty. So if we cut it, here we have, and the inside the inside circle is it's hard a little, will be like this. Suppose it's a circle, so the cut will be look like this. Now we again find the radius. So first one's radius is, this is -4. Remember, we rotated it about x equals to -4. So this is x equals to -4, and here we have this radius then. Okay, what's this? This is here, this line. This line is y equals to 2x plus 1. Then y minus 1 over 2 equals to x, right? Here we had x equals to, because we need to find this point, we need to find x, so we isolate x there. This is y minus 1 over 2. And we had before, this is till 0, right? We had before, this is y-axis, okay? We had before 4, then it is 4 plus y minus 1 over 2. Now, what about R2? Here we have R2. Let's okay, we need to draw it again. So here we had here we had the cut, okay, and this is R2. So we touch here. It is here, right? You can think of like this. Okay, so we touch there. Okay, now it is from here to there. We had -4. Okay, the y-axis here we have 0. We have 4 there and 4 here, so we have 8. Okay, on here it will be a little bit harder, because not harder, but this is y-axis. Okay, so here we had 4 till here, and there we have again 4, so it is 8. Okay, now as we did before, this is the area. The bigger one is pi r2 squared minus pi r1 squared. So we have this. Now what's the volume? From 3, as we did before, to 9. Here we have the result. Hope you understand. So if you have any question, you can attend the office hour. So see you there, and good luck.